extrapolating the concept of the single machine to parallel machines. From there, now let us look into something called as a flow shop. So, the flow shop is there is a lot of things that talk about the volume of production based on which what is this and how much, based on which setup to be used. But here we are going to look it from the layout viewpoint. So, a flow shop is a system where all jobs follow the same route. Okay. So, the machines are arranged in the order of flow. Okay. So, think about it as drill, mill, plane, grind, something like this. Okay. So, then the raw materials arrive here. So, you can think about that there is a drill machine, there is Q here. Okay. So, arrive, then the milling machine has its Q. So, once drilling is over, they will join the milling machine Q. From it is over, then it will go to the plane. Okay. Then from planing, once it is over, it will go to the grind. Okay. And once grinding is over, the finished product comes out of this. Okay. So, the arrive here, you will say that arrival rate is to the facility or factory. So, you can say that all these things, the drill, the mill, plane, grind, they will all have their own, all machines will have their own processing time plus setup time. So, for example, you can say that drill will take 6 minutes of processing time plus 2 minutes of service time, okay, or setup time. For mill, it could be 2 minutes of PT plus 1 minute of ST. Plane can be 6 minutes of PT plus 7 minutes of ST, and then grind can be 20 minutes of processing time plus 8 minutes of setup time, something like this. So, that means if you look into it and someone says that the parts arrive at the rate of 1 in every 10 minutes, then you can think that every 10 minutes the part will arrive. So, the drilling machine will finish the drill in 6 minutes, I mean 6 plus 2 8 minutes. So, this is 8 minutes, this is 3 minutes, this is 13 minutes and 28 minutes. Okay. So, the parts arrive in every 1 in every 10 minutes. So, they will keep on arriving, drilling machine keep on drilling in every 8 minutes and then move to the milling machine. It will finish in 3 minutes and then move to the planing machine. So, pretty soon you will see that when it comes to the grinding machine, the queue will increase, the queue will be longer because it takes a lot more time. So, if you stand here at this and look at time between two products, you can see it as 28 minutes, because once in every 28 minutes you will see one part coming out, because that is when the grinding machine is finished, that is when the part comes over here. So, now you know that okay fine, the grinding machine is the slowest in this case. So, what can I do? Can I put one more unit of grinding machine? Okay, I can say grind 2, this can be grind 1. So, from here it can go to either one of the grinding machine. So, then I can, if both the grinding machines are identical, let us say if grind 1 equal to grind 2 means identical machines, then I can see that in every 28 minutes, so every 28 minutes I get 2 parts or 1 part in 14 minutes. Okay. So that is another. So here you can see that this kind of a setup, this whole thing where all jobs following the same route is called as a flow shop. And here you can see I added a concept of additional 2 machines which is called as a parallel machine. Okay. So factories are built like this. Factories are built, these are all single machines. Okay. So you start with single machines and then you integrate single machines in sequence and all jobs following this one. So here you can see that when everybody follows the same sequence, it's easy to call it as a job rather than a task, because at the end of the day you get the same product. Okay. So this kind of a setup is typically used for high volume products. Okay. So and your aim will be to reduce these processing times. So here the aim when you have to produce large quantity, high volume products, which means large demand. Okay. If the product has large demand, it is better to set it up in the form of a flow shop or a pretty much what we call as a line, production line kind of a system. So this people call it as a flow line, or a production line also is called this way, and it can go in a much longer fashion as well. Then your aim is to reduce processing and setup times to increase rate of production. Okay. So that is what we will call as the in this case, in our course we would be studying quite a lot based on a flow shop like system, because it is important that most of the factories, the large volume production factories, high volume production where multiple shifts happen, that is where you can actually do the maximum amount of sustainable manufacturing initiatives, where you can reduce energy consumptions, reduce the coolant and all those kind of aspects. Okay. So this concept of flow shop is important for us in this particular course. So I hope you guys are all clear with this. Okay. And you can also see that the length of queues here. So this is the queue of plane. Okay. Queue of grind, etc. So these queuing concepts, the concepts of queuing are also important. So concepts of queuing is necessary, and I would request you to recommended reading for this case. Reading is the book on operation research by Taha. Okay. Take this and read the chapter on queuing. Okay. Read that and look at the simple examples. You will be able to understand. I will try to come up with one small lecture on the aspects of queuing, so that you can actually it will actually help you in understanding the concepts, but the detailed readings and how to solve those problems you are supposed to learn by yourself. So then comes the third concept called job shop. Okay. And job shop is like in a simple sense you can say that each job follows its own route. Okay. So in this case, the example, if I have to do this, the main thing is the machines are arranged in the form of departments that are decided by its similarity. So let me give you an example in this case. Let's look at a factory from the top. I'll kind of draw it at one side, because then I can draw the other flow layout on the other side. So if you look at a small factory like this, okay, I can have, let's say, G, G, G and G. So this will become, I'm drawing here like this way. L, L, L stands for the lathe, and then you have D, D, D and D. This stands for the drill, and then let's say M and M stands for the mill. So this will be your grinding department. Okay, this will be your drilling department. This will be your milling department. This will be your planing department or lathe department, whatever you want to call it. You can see that the machines are grouped by their functionality. So machines grouped by functionality. Okay. So if a part come into the system, so here is the receive dispatch. So the parts arrive, the raw material arrives. So one part will go to a lathe machine, then it will go to a grinding machine, then comes to a milling machine, and then it will come here and it will go out. Another part will come in, okay, and it will go to the, we will use a different color for, different color for this so that it can be seen differently. So another part will come here, okay, and then it will go from here to the another lathe machine. From this lathe it will go to another grinding, then it will go to a drilling. From drilling it will go to milling. From milling it will come here and it will go. Then the third part will be, it will come here. It will not go to lathe, it will actually go to grinding, then it will go to drilling, then from there it will come back to lathe, then it will go to milling, and then it will get out like this. So you can see that, okay, multiple products can be built in the same facility. Okay, this is amount to flexibility. Okay, so if you look into this, you can understand that the main aspects of this job shop system is flexibility. So if you look into the flow aspect of it, then you can have something like a, you can say it's a grinding machine, then there is a lathe machine, then there's a drill machine, something like this. Then you have another machine lying out here, a third machine lying out here, and another machine here, kind of a thing. So the products will, so you can have a, machine 1, machine 2, machine 3, machine 4, machine 5, machine 6. I'm just drawing it this way. So one product might come to machine 1. So this has its own queue. Okay. So let me redraw this part. So it will have its queue, and part will arrive here. Okay, and then it can go from there to machine 4. From there it can go to machine 5 and it can get out. Other part might arrive on machine 2. Okay, then it will go to machine 2. Then from there it will go to machine 3. Okay, and then from machine 3 it will come to machine 5. From machine 5 it will come to machine 6, and then it will get out. So this is part 1 and this is product 2, or product either way. So the product 1 flow is M1 to M4 to M5 done. Okay, product 2 flow is M2 to M3 to M5 to M6 and done. Okay, so you can see that each job has its own route, and multiple products might use the same machine. So here an example is M5, both of them uses M5. So here is a common machine. Okay, so when when more products start sharing a machine, it becomes critical. Okay. You can see that this shop has the issue of, so typically we call this as a scheduling nightmare. It's because it's not very easy to schedule a system in which all sort of haphazard flows happen. Okay. But the main advantage of this is it can use the same facility to produce multiple products. Okay. So you have flexibility, but you have a scheduling nightmare. So hence this is never high volume production. Okay. So these are low volume diverse products. Okay. And job shop is a common system also. Almost all the machining shops that you can think about are job shops typically. So this is like the the plan view what we talk about. Okay. And this is kind of the flow view we can think about it. Okay. And in between, if a machine breaks down, then all the hell breaks loose in the system. Okay. I hope you guys understand what I'm talking about. So there is like in this case, depending upon the product, each product has its own arrival rate. Okay. And because of that, your queuing is also a big mess, because it goes, I mean, depending upon what rate the systems are, the parts arrive, your queue will also go crazy. Okay. So I hope that you guys now understand the criticality of dealing with the job shop like system. In this course, we are more interested in dealing with a flow shop like system where things follow a uniform flow in this regard, and this is much more what you call much more efficient. So the advantage of the flow shop is it is more efficient compared to the job shop, but it has less flexibility. Okay, that is a disadvantage. So, and as we said earlier, here it is more flexibility, but less efficient. Okay. So then obviously whenever you have two extremes, you will try to see, can I come across a scenario where I can kind of merge both of them? Obviously yes, people have done that, and some people call this as a batch production system. We will not spend too much time on this because this is still complicated for understanding the concept of sustainable manufacturing, but you need to be exposed to a system like this. So batch production system, batch system marries job shop and flow shop. Okay. So it's an intermediary, at the end of the day it's an intermediary between flow shop and job shop. Okay, that's called as a batch production. Okay, why do we marry this? It gives best of the both. Okay, what is the best of the both? It is, what you're trying to do is flexibility and efficiency. Okay, so efficiency means you can produce large volume in less time. All right. So not you can, I mean, what we are you should understand that is the best of the both to some extent. This is the most important part. It doesn't mean that you will get all the benefits the same exact rate. To some extent you will be able to get the benefit out of it. Okay. So the batch production system at the end of the day is flexible like a job shop, but is capable of producing moderately high volumes like a flow shop. The most important term is moderately high volume. Okay. So you can have some more efficiency, built into a job shop while retaining the flexibility. This is the concept that we are talking about here. Okay. So, what we would argue in this case is we can say that what happens in a batch production is similar but different products are produced using the same facility. You have the same factory in which similar but different products are produced. So, you might be producing gear wheels or like helical gears, but different diameter helical gears are used or something like that. So, different products, but they are similar. The products are different but similar. Similar means similarity in operations or processes. Okay. So, the shape might look different or some other performance characteristics might be looking different. So, like for example, you are making the same, like let us say this is a gear wheel, you are making the same gear wheel. My gear wheel drawings are horrible, but still I think it gets the point across. One could be of iron, as could be of aluminum. This is one possibility. Another is their diameter differs, okay, number of teeth. Okay. So, but these are by two different products. This can be a product 1 and this can be a product 2 easily, but they are similar because at the end of the day they are both gear wheels. Okay. So, in this case such kind of a system, the similar but different products are produced using the same facility, machine and workforce. So, the factory remains the same, the machines remains the same, the workforce remains the same. But what happens is when you switch from one product to another, whenever switching from producing one product to another happens, a setup time or a cost is needed. A classical example of this is a paint shop. Okay. I would like to bring your attention to this. So, if you have a painting booth, okay, let us call this a painting booth. Okay. So, the cars are lined up here. Okay. My cars does not look like a car, but still kind of gives you the dumb idea. Okay. So, the cars are waiting to be painted and the painted cars get out. So, here what happens is you will have a car that is, this car should be painted yellow, this car should be painted black, then there is a car that comes in the back that should be, this should be painted white like this. So, cars are waiting to get painted. Okay. Now, here the problem is once you paint the car with the yellow, you need to change over the color to black. Okay. So, the changeover of the color, changing the color from black to yellow, yellow to black, black to white, okay, it creates a problem. That is where the setup time, because you need to clean the nozzles and everything. So, it would have been nice if the painting was, currently it will be yellow to black to white. This is the painting sequence. Okay. Whereas, if it was been white, yellow and black, then you would have resulted in much lesser setup time, because flushing the nozzles and everything with the after black paint to a white paint is quite time consuming than flushing from yellow to black or white to yellow. So, it is usually better to paint from lighter color to a darker color. So, this kind of a setup, okay, this is called as sequence dependent setup. The sequence dependent setup means the order of production determines how much of the setup time is used. Okay. So, in a batch production, sequence dependent setups do take a significant stuff on this, but that is outside the ambit of this course. So, we would rather like not to spend too much time on it, but you should know that there is a option like this. So, then now that we talked about the concept of sequence, so let us see what is sequencing, and then we will kind of conclude after this, and then we will move towards optimization in the next lecture. So, sequencing and scheduling, when we have been talking about schedule is that allocation of resources over time, and sequencing is also something, but they are similar. Okay. The concepts are similar. The major difference is sequencing does not refer to time. Okay. The time frame or the start stop times are not part of the sequencing. Okay. So, that is the difference between sequencing and scheduling. In scheduling, in contrast, produces a detailed plan of various activities over time. So, scheduling considers over time, sequencing does not consider the time. Okay. So, scheduling has time, sequencing no time. Okay. Or some people we can say that some simple rule to decide what to do next. Okay. So, this is sequencing. Okay. So, what we talked about here is, now here is an example for you, a bank teller in another way to talk about is a bank cashier. Okay. The cashier processes 5 customers on a first come first serve basis. The first come first serve means the person who comes to the, so like if you think about this as the bank cashier, okay, there are 5 customers, okay, 3, my stick figures looks like human beings, okay. So, this is customer 1, customer 2, customer 3, customer 4, customer 5. So, this guy came at 10 a.m., this guy came at 10:05, came at 10:20, 10:40, 10:45, something like this. Okay. And here is the cashier and processes the customer in the order at which they arrived. So, here even if it does not matter, even if they came at 10:02, does not matter, customer 1 will be processed. So, this kind of a system where the order in which they arrived is process is called as a first come first serve or first in first out. These are the terminologies that is used. Okay. So, there is no planning, you basically say whoever came to the queue first will be processed first. So, without any planning about the exact start and end times of each customer. Okay. Customer came in, whoever came first gets processed first. This kind of a mechanism is called as sequencing. You can see that you still, this guy is processed first. There is some point once the processing is over, you can say this customer was processed from 10:02 to 10:12. So, it took customer 1 it took 10 minutes to process, and customer 2 it took 4 minutes to process, customer 3 it took 17 minutes to process, customer 4 it took 2 minutes to process, etc. Like customer 5 it took 7 minutes to process, something like this. So, each customer can take different time, but the order in which they were processed is that order in which they arrived into the system. So, whoever came first was processed first. Okay. So, given such kind of a system is what we call as a sequence, just a sequencing system, not a scheduling system. A sequence becomes a schedule when you do a time frame. Okay. Sequence becomes a schedule when exact start and end times are provided. All right. So, that is what it is all about. Okay. Now, I guess with this we have covered sufficient concepts to learn the aspects of manufacturing, especially moving towards sustainable manufacturing. We have seen what are the different ways we can actually create models of various manufacturing processes depending upon the layout and as well as the process flow, and how the single machine concepts can be elaborated to do a parallel machine, flow shop, job shop, and what is a batch production and what is scheduling, sequencing, that aspects. And we also talked about arrival rate and those kind of stuff. In the next class, we will look into some of the basics distributions that are used in different manufacturing processes. Then we will look into optimization and then other aspects of supply chain as well. So, I hope you guys are enjoying this course, and we will see you next time. Thank you very much.